So the new KPI were introduced a few years ago. We published at ETSI technical reports to explain the methodology. And for the first time, we started as industry to look at the end-to-end performance. So we wanted to have wireless backhaul to be integral part of an end-to-end connection from the base station to the user equipment. And we specifically looked at the quality of experience that we wanted to preserve the quality of experience without over-engineering with a wireless backhaul. So we introduced the concept moving from capacity to traffic, and we wanted to measure the wireless backhaul not on the capability to transmit a certain capacity, but to transmit the traffic that was required. This permits not to over-engineer. Not to over-engineer means to reduce costs, both TCO, the OPEX and CAPEX. CAPEX because it means lower antenna size or longer links in frequency bands that maybe before were not possible. This means lower tower rental cost, lower spectrum license fees. So overall is a very big improvement of the total cost of ownership for the wireless backhaul. So you said correctly, the scarcity of spectrum resources, also because there's need to accommodate other services or to widen services that are offered in lower frequency bands. I'm talking of IMT moving from 4G to 5G, 5G to 6G, or satellite, so for the non-terrestrial networks. So we need to optimize the way spectrum is licensed, and not only because of this, but also because we think the best way to deploy new features that can permit improving the spectrum efficiency, not only on the link itself, but spectrum efficiency from geographical perspectives, can be done with different type of licensing. This licensing should make an exclusive use of channels or spectrum blocks to each single operator. This has advantages not only in terms of deploying features, but because the responsibility of the network planning lies entirely in operator hands. National spectrum regulators don't have enough resources to plan interference management planning like it was done before. So moving this responsibility to the operators can really improve the overall planning, interference management, deployment of new features, but also a lot of advantages in terms of supply chain. The operators know exactly which channels they have to use. They can order in advance without uncertainty that the channel would be or not authorized by the spectrum regulators. In several directions, dimensions. Before the market, we always moved to higher and higher frequencies, so moving from 15, 18, 38, then E-band. Now we are talking of sub-terahertz band up to 175. And this is important because the higher the spectrum, the wider is the bandwidth of the channel, so this means higher capacity. Of course, this is limiting the distance we can cover. So we have to intervene with technology in order to compensate this decrease of op-lengths because of propagations by having more efficient, more powerful devices, especially power amplifiers, better antennas, so a lot of innovations in the antenna that can be used not only to span longer distances, but also to compensate what could be issues when we have very high gain, so compensating movements by oscillations of the pole or by sunflower effect under the sun. Antennas to introduce spectrum efficiency like the full duplex, or antennas like Uranus that we are presenting that can be multi-band, multi-link in a very compact that can permit operators to save again OPEX, reducing the tower rental cost, installation costs, and so on. So I would say multiple directions, but with the objective to make microwave, millimeter wave more and more competitive. We know fiber penetration. Without fiber, there could be microwave, but in the meantime, to make micro millimeter wave still a competitive choice for operators for the wireless backhaul.